It was Jacques Charles who experimented on the relationship between the volume of a gas and its temperature, and formulated the what we call Charles' law, which states that the volume of a gas is directly proportional to its temperature at constant pressure and amount of gas. This means that as the temperature increases, its volume also increases, or as its temperature decreases, its volume also decreases. Expressing Charles' law in symbols, this will become volume is directly proportional to its temperature. Expressing this mathematically, this becomes volume is equal to a constant times temperature. Or this can be simplified as volume divided by temperature will give us a constant value. So, Charles' law now can be expressed as V1 over T1 is equal to V2 over T2 with the condition that it should have a constant pressure and amount of gas. We will now be using this formula to solve Charles' law problems. Let us now apply the formula in solving problem number 1. A sample of nitrogen gas occupies a volume of 3.0 liters at 20.0 degrees Celsius. What will be its new volume if it is heated to 65 degrees Celsius, assuming that it is a constant pressure and amount of gas? To solve the problem, we are going to write all the information given by the problem. Start with condition 1. V1 will be 3.0 liters and temperature 1 is 20.0 degrees Celsius. Convert this to Kelvin scale, so plus 273.16 will give us 293.16 Kelvin. While condition 2, volume is the unknown and the temperature is 65 degrees Celsius. Convert this to Kelvin scale, so plus 273.16. So will give us the value of 338.16 Kelvin. Using the formula, V1 over T1 is equal to V2 over T2. So we'll substitute all the information, all the given values to the formula. So this will become 3.0 liters all over 293.16 Kelvin is equal to V2 all over 338.16 Kelvin. This is V2. Okay, transposing this to the other side so that the volume 2 will remain on this side of the equation symbol. So we are going to multiply this by 338.16 Kelvin Also with this one, so that will not be changing the expression, multiply this by the same value. Okay. So, this will cancel. So, what will remain here will be our V2, the unknown. And then, this one unit will cancel with this one. And then, using your calculator, 3 divided by 293.16 times 338.16 will give us a value of 3.5 liters. Let us try problem number 2. Calculate the decrease in temperature when 5,750 cubic centimeter at 50.0 degrees Celsius is compressed to 4,250 cubic centimeter. So we will now write all the given information. V1 is 5,750 cubic centimeter. And its temperature is 50.0 degrees Celsius plus 273.16. So this will become 323.16 Kelvin. Okay, for condition 2, okay, the volume is 4,250 cubic centimeter. The temperature is unknown. So, writing the formula, this will be V1 over T1 is equal to V2 over T2. Okay, we'll substitute all the given information or values to the formula. So this will become 5,750 cubic centimeter all over 323.16 Kelvin is equal to 4,250 cubic centimeter over T2. The unknown is at the denominator, so we will do cross multiplication. So this will become 5,750 cubic centimeter times T2 is equal to 4,250 cubic centimeter times 323.16 Kelvin. Transposing this to the other side of the equation symbol, this will become over 5,750 cubic centimeter. Do the same here, over 5,750 cubic centimeter. This unit will be cancelled. This will become 1. So therefore, T2 will be equal to 238.86 Kelvin. What is asked is the decrease in temperature. So, to answer the question, so the change or decrease in temperature will be equal to T1 minus T2. Okay, so this value 323.16 Kelvin minus 238.86 Kelvin will give us a value of 84.3 Kelvin. Let us now proceed to problem number 3. An expandable container contains 6,500 milliliters of argon gas at 65 degrees Celsius. At constant pressure and amount of gas, what will be its new temperature in Celsius if its volume is reduced to 4,900 milliliters? So our V1 is 6,500 milliliters and our T1 is 65 degrees Celsius plus 273.16 will give us a value of 338.16 Kelvin. For condition 2, we have V2 as 4,900 milliliters and T2 is unknown. So the formula for Charles' law is V1 over T1 is equal to V2 over T2. We'll substitute now all the given information to the formula. So this becomes 6,500 milliliters over 338.16 Kelvin is equal to 4,900 milliliters over T2. Again, the unknown T2 is at the denominator. So we're going to cross multiply. So we will now have 6,500 milliliters times T2 is equal to 4,900 milliliters times 338.16 Kelvin. We'll transpose this to the other side of the equation symbol. So this will be divided by 6,500 milliliter. We'll also divide this by the same value, 6,500 milliliters. Okay, so this cancels. This will become 1. Using your calculator, 4,900 times 338.16 divided by 6,500 will give you, T2 will be 254.92 Kelvin. But the problem wants us to express our final answer in degrees Celsius. So all you have to do is subtract, okay, from 254.92 minus 273.16 we'll get the value of negative 18 degrees Celsius. So that's it. Thank you for watching and please don't forget to subscribe.